so I'm going to try and go through. What I normally do is I teach this course in 8 hours, and that's not the crash course. So what I've been doing all day is just whittling it down so I can get through this fast. But I don't want you to sweat it because I'll make the slides and some other stuff available afterwards. So this is going to be fun. I am the CEO of a company called Peripety Labs. Anybody know what the word peripety means? It means when the hero knows he's wrong. I had a corporate job, and at some point I registered that domain and knew this was going to happen someday. Now my main thing that I do is I consult with emerging tech companies and high-tech companies with their AI strategies. So my customers are people like Docker, Pulumi, IBM, MongoDB, Intel. And what I really like to do is write. I used to be the editor-in-chief of Linux World magazine back when there was a Linux World magazine, Enterprise Open Source magazine, like 20 years ago. And now nobody will give me a job writing because I'm a little opinionated, so I just write my own stuff. And that's the AIE.network, the Artificially Intelligent Enterprise Network. So that's a little bit about me. My corporate gigs, I was the VP of Marketing for Linux Foundation. I worked side by side with Linus Torvalds. It was very cool. I worked at Citrix, where I started their open source business office. I worked on things like OpenStack, the Zen hypervisor. And so I have good open source chops, but every time there's a new tech trend, I switch. So I was at cloud.com, I was their DevRel VP, and then I went to do some stuff with Kubernetes. I had a startup called TriggerMesh where we did open source event-driven integrations. And today I am doing stuff in AI, hoping to catch the wave. So anyhow, this is just sort of what the AIE network is. The newsletters are all free. They're all designed to help people learn. The thing I realized doing DevRel stuff is I like to introduce people to new technologies, help them understand it. The one I write specifically is the AIE, or is AI Enterprise. Anybody DevOps people in here? AI CIO is written by John Willis, the author of the DevOps Handbook. AI Tangle is like the morning brew for AI. And then the AI marketing is self-explanatory. And then AIOS is where I put my courses up for free. So I normally don't do just open source. I do all of that. So that's sort of the derivative. And you can do a 14-day free course with a lot of this content. So don't sweat the fact that we're trying to do 8 hours of content in an hour. We'll get there. If you want the slides, if you go to bit.ly/AI Scale, you can sign up there and I'll send you the slides afterwards. That's my newsletter sign up, but it's going to tag that you came in to Scale and that you can get the slides. Plus I have some other bonus stuff for you. Another thing I do is something called All Things Open AI. Has anybody ever gone to All Things Open in Raleigh, North Carolina? It's like the Scale of the East Coast. So in a week, we're doing a conference there. If anybody wants to attend, feel free to go. Use the code SCALE22X. There's a free day of training. Is that a sign from above that I should not be giving this talk? But, well, that'll be fun. Anyhow, the first day is a full day of training, and normally that costs $500. If anybody has friends or wants to go, it's free because you came to my talk today, and you can get all of this stuff here. So none of it costs anything. I just put it out there because it's hard to get all of this out in the talk. But before we get to that, I'm going to give you my AI conference hack. So last weekend, I do newsletters. I went to a newsletter conference. This is the best hack I found is if you have the ChatGPT hack, which I know ChatGPT is not open source, but you can go and give it the prompt that says, I'm at this conference, remember everything. And as you see slides and things you like, you can take pictures on the app, you can record snippets, you can type notes, and at the end, I tell it to summarize it. It was an experiment last weekend. It gave me a nice brief of all the talks I went to the day. So that's my AI hack. You could be, if you're an open source person running GPT for all, I think you can use it, but the thing that's cool about it is if you hit the search in the toolbar and you don't quite get the name of something, it went out and found the stuff and gave me hyperlinks in that. So that's my overall AI hack for conferences. So normally what I teach people is how AI works and then how to apply it to their job. I think AI is probably the most interesting tech trend that I've been around for. And I worked for the first international ISP PSINet in the 90s when people dialed up with the buzzy modems at 9600 baud and were amazed. So I'm trying to get all of that into 1 hour, and we're already at 7 minutes in. So I'm going to go like an auctioneer, but you have the hack. Take the pictures, use ChatGPT. You can get the slides afterwards, but I'm going to try and cover a lot of stuff that I think is interesting generally in AI, and then I'm going to apply the things that I know and like as far as open source goes. But I'm going to teach you how it works, and then where the sort of open source stuff is alongside that. So how many people here use ChatGPT? How many people here use something other than ChatGPT? Anybody run their own large language model? Use like GPT for all or Ollama? So cool, that gives me a little context. So it all starts with the data. So it's just like when we start with a large language model, it's an algorithm. It's like a baby. When it's born, it doesn't have a lot of information about the world, so we got to give it information. And so we rely on a lot of information to do this. And I think I'm losing my thing here. There you go. Is that better? All right. So what we do is we got to collect our data. Now, as an individual user or an enterprise user, what you want to think about is what data you have and what you want to apply to a large language model, and what kind of data you want to share with other people who may use your data for, their own personal gain, and what data you want to keep private. And the reason that you want to gather all that data is the more data the model has, the more information it has about the world. This is why it's always in the news. OpenAI is, I think, settling with the New York Times now. New York Times, because they scraped the web, violated everybody's copyright, trained their models with it. Adobe did the same thing with their vision models. And now Google is buying Reddit data because if we're human beings, the way it works for us is we eventually read stuff, but before we read stuff, we see stuff, we hear stuff, we touch stuff. That's sort of the hole in the data, is we don't have much spatial awareness of the world if you're a large language model. I just anthropomorphized a algorithm, so that's also a problem with AI, is it's just an algorithm. It's a machine. It doesn't have feelings. As creepy as it is when you have a conversation with it, you sort of feel like it, but the amount of data that they've collected to train ChatGPT, or which is one of the biggest ones, DeepSeek's the other big one, Meta's Llama, is about the same amount of data that a 4-year-old child has collected. Because if you think about the bandwidth from vision, touch, smelling, hearing, sight, it's a little late in the day. I didn't have enough coffee yet, but all that data, if you just measure the amount of data, it's not even close to an adult. And so we got to remember that today, where large language models are, and all AI models are they're like they're infants. They're small children as far as their understanding of the world. And until we get more and more data in there, it's never going to be as capable as a human being. But in certain aspects, it is. So if you think about a large language model, Gemini, ChatGPT, Llama, whatever, it's basically like a librarian that has read every book in the Library of Commerce and has instant recall. Now, if for whatever reason that of all those books, They had pictures of dogs, and they had pictures of deer and cows and horses, but they didn't have a picture of a cat. It wouldn't know what a cat is. So if we show it a picture of a cat, we ask it, do you know what this is? And it'd say, well, it sort of looks like a dog, but because it hasn't seen that, it can infer it's something different than a dog, but it wouldn't know what it is. So that's sort of the overall why you want to give it all this data, so it has the understanding of the world. All right? So we have all this data, and it's structured, it's unstructured, and it's in all sorts of places. So we have data in our email. We have data in, our My Documents folder. Our companies have data in our HR records. And all of this data is in different formats. And what we want to do is process that data, clean it, and organize it in a way that these models can consume it. So if it's images, it uses a training algorithm to bring that in. If it's large language models, the two most popular open source ones are PyTorch, which is something that came out of Facebook that is open source, so that's how you train the data into the model, or it could be TensorFlow, which came out of Google, and that's open source as well. What it's doing is taking that data and learning from that data. And this is just a little Easter egg. I was on the floor walking around today, and I met these guys, Oxen.ai. They are a tool that does that kind of thing, that helps you take that data, and what you do with the data is you want to give that data context, so you label that data. And so if we had a bunch of pictures for a vision model, so a vision model is something like DALL-E from ChatGPT or Midjourney or Stable Diffusion, we would want to, if we had a picture of a cat, we say this is a cat. So it might know what a cat is, but it doesn't know what a cat looks like, and you label that to give it context so it can learn. Just like when you go to school and you're like in kindergarten, they have picture books. This is effectively what we're doing at a massive, massive scale. Imagine going to kindergarten for like 500 years. That's what we've done in a couple years. But what you do with something like this is you take your data, unstructure it, you label it, and then you prepare it so it can be consumed by the model. And then you can store that data, and you can store that data where the way we store data in AI world is we store it in vector databases. So I went to school for engineering until I decided that I wasn't cut out for it, but I did all the math. So anybody here do vector math in college? Basically, so when we think about a database today, it looks like a spreadsheet, right? Rows and tables, or we look at something like a NoSQL database, which is a key value store, which is a big columnar thing that allows you to have an identifier and then a piece of data. The way vector databases work is they think of it in three-dimensional space. So they have these vectors, and because you're using this three-dimensional space, you can use triangulation to get data clustered in a way that has multiple relations. And so that's how you go through a lot of data really, really fast. So that's also the reason why NVIDIA is the hottest company on the planet. So any gamers in here? Ever build your gaming rig with an NVIDIA card? The reason that NVIDIA is really good at that is that the kind of math that makes 3D graphics is triangular math. So that when AI came around, that triangular math, that's why NVIDIA went from, oh cool, GPUs, to now everybody wants GPUs, is because that helps you search through that vector data. Here's the open source databases, and I think the majority of folks probably use open source vector databases for what they're doing. I listed a couple of them, but the two that I'm going to really talk about are Milvus is probably the most commonly used open source vector database. And what you do is you take the data and you embed it, and there's like a process to take that data and turn it into those triangles, like put it in there in those triangles, or put them in vectors, and allows it to triangulate. The embeddings and the way you put it in there is really important for how performant vector databases are. Like I said, I took the math, didn't do very well, but that's like sort of the secret for performance to allow the large language models to search for it. The other one that's interesting is I think I like Postgres. A lot of us use Postgres. It's one of the most common, he's cheering, all right. It's one of the most common databases in use in the world. They have their PG vector extensions for that. The thing that I think is going to be hard for a lot of folks is you have data stored everywhere, and now you've got to take it, collate it, put it in vectors, or you can search and do something else called retrieval augmented generation, or RAG, where you can query your existing databases and sort of recompile it and make a query against the database. And I've just so oversimplified that every data scientist in here is like, you're such a moron. But anyhow, it's all right. But what you're doing is you're taking that and making it consumable by these algorithms that run these large language models. So open source vector databases, if you're doing, there's as a service, there's one that's sort of popular is Pinecone. If you use MongoDB, they're sort of in the middle. What they have is vector search, but they're a document store, so they're sort of storing their documents and they're translating and sort of making some on-the-fly conversions so that, say you already have you have a web app and you have tons and tons of records in there and they're always updated. You might use something like MongoDB Atlas, and they're sort of open source. They're like a little there for a while. I think they have a lot of open source stuff, but typically what you're doing is consuming them as a service. All right? So then we have this thing, machine learning. Machine learning is really the precursor to generative AI. And basically what that is algorithms that go look at your data, they look at patterns, relationships, and using statistical techniques. A lot of people today say they're doing AI. What they're really doing is still machine learning. Because, like I said, the large language models, some of these other AI models are 4-year-olds. So making them a little bit smarter and doing sort of things like that, machine learning is still a big part of AI. Then we have something like deep learning. And then this is where, did I put deep learning before? Yeah, I want to go to the machine learning models. Sorry about that. So you have things like supervised learning, and that's where you're learning and you're labeling and there's people watching it. The unsupervised learning is when they're sort of letting the algorithm make the decisions, and then there's reinforcement learning. So example of anybody that uses ChatGPT and you know the little thumb on the bottom that said, was this a good answer? That's actually that's humans in the loop to give feedback or reinforce whether the answer was right or wrong. So they're using that to start to like distill bad answers for good answers, get better, get it from the 4-year-old to the 4.5-year-old. Okay, I'm gonna go back. Then we have this thing called deep learning. And deep learning is, think about it this way, it's layer after layer of like iteration over and over again. So it's like when this is dating me, like the old inkjet printers, or they would sort of make multiple passes to fill in the dots. That's basically what happens is we sort of sketch out the outline and then we fill in the spaces until we get the whole picture. That is a simplification of deep learning where all of these layered neural networks process vast amounts of data. So, okay, let's go back to, and I think I took out one part that, trying to make this quicker, but then we have the things that are interesting about AI is this idea of neural networks and GPTs. So the neural network, they say, mimics the brain, which is funny because we still don't really know how the brain works, but we're going to use an analogy of we don't really understand this one thing, so we're going to put something else we don't quite understand on top of it and give an explanation. And I'm furthering that process here today. But these neural networks are going back and forth and iterating on this data. And you know, the big breakthrough that started generative AI was something called a GPT. So that's why it's ChatGPT, is this transformer model. And the way that they came to this is somebody ran over their AWS bill. So this is what they used to do, is you would run these training runs, and at some point, if you overtrain the model, it does something called overfitting. So it's looking at the data so much that it actually gets worse results than better. But if you forget to turn off the process, leave it for a couple days, what happened was it overtrained it to the point where it started getting better again, and that's how the GPT came to effect. So if you want to learn a little bit more about that, Google published a paper called Attention is All You Need. That's sort of like talks about how that happened. But that's where we are today. So we've gone through that. The thing that is in the news all the time right now is generative AI models. So from ChatGPT is the latest and greatest right now is GPT 4.5. It just came out, I think, like a week ago. It's very in the last couple weeks. And then the one that has been in the news, how many have seen the DeepSeek headlines, right? Dropped $1 trillion of value off the S&P 500 and all these companies because people are sheep. And we get scared and we run away from the wolf. And DeepSeek was the wolf of AI, not the wolf, and apparently now the wolf of Wall Street. But what happens with these generative AI models is we talked about machine learning. It was analyzing patterns and data. So we've analyzed the patterns of data, and now we're actually creating something. Before, machine learning is actually sort of summarizing, learning from the patterns of data. Generative AI is, I type in something like, tell me a story and about a wolf and a dog, and it would write out a story like a wolf and the dog, and it's actually had enough context. It's like a little kid telling you a story that they made up in their head. And that's interesting because it's creating stuff. So generative AI models like that. We have Stable Diffusion, which is another model for vision, where it's looked at a lot of pictures and now it can do that. My favorite one is Midjourney. Does anybody here use Midjourney? Yeah. Anybody use Stable Diffusion? DALL-E is the one from ChatGPT. I think Midjourney I like the best because you can sort of, like today it's sort of like, I don't know, anybody have a spirograph when they're a kid where you sit there and spin around and you reverse and it's, you sort of guiding it, but you sort of didn't know what was going to come out? That's sort of where we're at today. In a couple years, it's going to be more like a paintbrush, like with Illustrator and Photoshop or Inkscape or whatever your open source editor of choice, the GIMP. And you're going to be able to sort of paint with it more and have more control. But today, what it's really doing is you're sort of giving it seeds, you're giving it a description, you're saying how much chaos, distortion, noise, all these sort of things, depending on how they name the parameter. And then it sort of, like you say, draw a picture of a dog. I'm a dog guy, so all my analogies. I miss my dog Woodford. He's at home in North Carolina today, so probably have way too many dog analogies, but give it a picture of a dog, make him fluffy, white and black, make him look like a sheepdog. Sometimes he does look like a sheepdog when I do that. Sometimes he looks like a sheep. And it's a problem of the fact that you're trying to guide it, but that's what generative AI models do, is they take what they know, take your seed, your prompts, and all this stuff, and try and make some sense of that. So I'm going to talk about open source models. So open source does not translate well to large language models. So I'm going to talk a little bit about the models and which ones are open source and why I think they're more open source or less open source. And then I'm going to talk about why it doesn't really translate 100%. So the first one that Mark Zuckerberg talks about is Llama 3, and that's from Meta. And it is a good model. It is a free model. It is not open source. It is free to use, but if you use the open source definition, there's some things in the open source definition that says no discrimination against groups. One of the things in the Llama model that is my gripe is And it's not a big group that it discriminates against, but if you use it for something and you have more than 600 million users, then you got to go get a license from Facebook or their permission at least. So if you start building something like you're a student at Harvard and you do stupid stuff, and then all of a sudden you create a social network and all of a sudden it gets really, really big, you could be in a world of hurt when you hit 600 million and one users. So that's why I don't like that as an open source model. For most people, I think it's pretty capable. It started out as a large language model. So the large language model is text in, text out. Now it's a multimodal model. Multimodal model means text in, images in, text out, images out, and you can specify that. Most of the models now are that way. Gemini from Google is a multimodal model. But if I'm looking at it, we have Llama, probably one of the biggest, most capable ones. Mistral. Mistral is a French company. They really are open source. And their models were sort of innovative because they did something called mixture of experts. So think about, instead of having like the librarian that I talked about earlier that read everything, imagine you have a librarian, you have a professor from Harvard or somewhere, MIT, somewhere good, and you have someone who's an expert in nature, an expert in whatever, chemistry, biology, whatever those things are, and then you think about there's sort of a director at the top. And that director says, your question is about, dogs. So it goes to, of course, and it goes to the biology expert. And you have a question, and it's about, chemistry. And you go to the professor of chemistry, and it's computer science or coding. You go to the MIT expert, and it decides that you don't have to go to this big, huge, super smart oracle, no pun intended, of an expert. Because the problem with that is when you use the big brain, you use more compute, you use more power, it's not efficient, and it's not going to give you a better answer in a lot of cases. So there's this idea of the lead expert orchestrator that decides which expert the question goes to. This is the pattern I think we're going to see in the long term. What you're going to have is something called an LLM router, and there's an open source project called LiteLLM. And what it does is it can route your question to 100 different models. And that way, if you train a model, your own personal model, it can go ask your personal model. And if you have a general question, it can go to the general model, like ChatGPT's GPT-4 or Gemini or Llama or wherever you want to go. And that way, you can go to the expert model that's best for it. So right now, it's all packaged together for somebody like Mistral, DeepSeek, which we're going to talk about. That's a mixture of experts. I think that's the design pattern, not only for efficiency, but privacy. So if you're a company, you might have your intranet LLM directing stuff to ChatGPT. If you're asking like general questions about like the stock market or news or current events, maybe even marketing. The thing that's cool about ChatGPT is the web search index. Same thing with Gemini. They have Google's web search. So it can actually, rather than you have to type everything in, it can go search the web, do the research, come back, rather than you tell it what, all this stuff and have it analyze the data. Like when I write my newsletter, if I say, I want you to write like me, go look at the AIE.net to see what we write, and it can pull all my content without it having to train it. It's going to, on the fly, go do that web search and help inform my query. So that's why I like ChatGPT, because it's the LLM with the search capability. Gemini has it. There's two things that I really like right now. Well, actually 3 models that do it pretty well is Gemini, from Google, ChatGPT, and then DeepSeek all have web search capabilities. And so when you do that, you don't have to like cut and paste the web page in there for it to analyze something that it wasn't trained on. Then there's Falcon. Falcon is actually The reason it's notable is it was trained for Arabic languages, so it was, I believe, came out of the UAE. I put it in there where it came. But the thing is, it's a different character set, and it was specifically designed to be trained on that kind of character set and that knowledge. Bloom was an early one. Bloom is a scientific model. Bloomberg, actually the big financial data company, built their own model, and I think they used Bloom to analyze, because they have going back to the data thing, they have 100 years of data, and some of it's public, like stock market performance, and other is what the deep state people have been doing for 100 years, and they have access to that, so they're training on that. And I'm just kidding, there's no deep state. Fine. Finally, the one that I really like, as far as if I was doing it, and I used to do useful stuff like run web servers and DNS for millions of people, and if I was doing stuff for my own infrastructure, I like the ones from IBM, and that's Granite. It's true open source. The reason I like it is because they have a little bit more rigor in their process. ChatGPT tried to license Scarlett Johansson's voice. She said no, and then all of a sudden the new ChatGPT mobile app comes out. Sounds a heck of a lot like Scarlett Johansson. So I think there's a little bit of the cowboy. I'm a startup guy. We're cowboy a little bit, but if you really want to do, conservative, know that the models are coming from a place where there's rigorous engineering process. I like Granite. I know the guy who is the head of engineering for Granite lives in my neighborhood. He's a nice guy. I trust him. I don't know. He could be, have multiple personalities, but I sort of doubt it. And then finally, we have DeepSeek. So let's talk about DeepSeek. So DeepSeek is open source, legit license. I think I put it here. I think it's at MIT. Yeah, MIT. So MIT license is very permissive license. You can take it. There's not a lot of any restrictions that are significant on it. Do whatever you want. And the thing that made DeepSeek interesting was, first of all, all these announcements about how performant it was, and they trained it for so cheap. I don't think that's true. The problem was DeepSeek is in China, and we have export restrictions from NVIDIA. So technically, there's only supposed to be so many NVIDIA GPUs in China. So it's very convenient that it falls within that thing. Ironically, though, Singapore, which has 107 data centers that probably all could fit in this room, has bought a lot of GPUs, and I don't think they have enough power to power them. So, if you are a conspiracy theorist, which I don't know conspiracy, but I'm not dumb either, or not that dumb, I would say that they probably have bought a bunch of GPUs from there. So the fact that they trained it cheap, I think that's sort of a red herring. The one that was trained cheap that's really capable is the Sky model out of Berkeley that they trained for $500. I think that is more of an interesting thing about training a high-performing model with a very little amount of resource. But the thing that's cool about it is they published how they did it, and what they did is going to filter down into all the other models, closed source and open source. And the way these models work, I'm not going to go super deep in this because it's geeky. I tried to dumb it down, but I had to go read the paper twice to figure out how to dumb it down the best. But the multi-head latent attention, basically what it's doing there is reading between the lines. It's sort of taking this data and it's inferring on the fly. The way that we normally would look at data is, in a large language model, is you take and we'll go into this a little bit later, is we take your data and we convert your words into something called tokens. So these things don't actually speak English. What they do is they take your words, they break it up into these little pieces, and then they use statistical methods to guess what the next word, the next token is, not even the next word. So TH might be a token, EAR might be a token. They don't know putting them together is there. They just know that these are tokens. They use statistics and they guess at the most likely word. So if I said the quick brown fox probably ends up with jumps over the lazy dog, because of probability. Stuck another dog in there, by the way. The other thing that they did that's related to that is the multi-token prediction. So the way that I just described it was single token prediction. What they said is, let's look at 5 tokens and then guess at the next 5 tokens, and that's a more processing efficient way to do it. And that's why they were able to make a lot of change of advancements. The other thing that they did that is just better expert management, like we talked about earlier, that mixture of experts. They were just, they created the committee of experts. And so rather than just pick one expert, they picked a couple that were sort of, you know, adjacent to try and make better guesses. So that's the other thing. And then the final thing is this FP8 precision training. Let's just say that they used memory better than they did before. And we're all talking about how hard it is to get GPUs. The next shortage I see coming is DDR3 RAM, because these models require a lot of memory and what we know as conventional memory. So those 4 things are why they were better. But they told everybody. So it's like they made cookies. They made those, what are those, Mrs. Fields cookies that everybody loved. And they shared the cookie recipe with everybody. Now everybody can sort of tweak the recipe, and maybe somebody's gonna do something awesome like put gummy bears in their cookies, and we're gonna love them better than the chocolate chips. But that cookie recipe is now available to everybody in the industry. And this is why open source is great, is the shared innovation. So I'm not a fan of DeepSeek from the standpoint of I wouldn't use it, simply because their training data, if they adhered to the Chinese state, is trained on data behind the Great Firewall of China. So one of the things I did was ask it about any significant events at Tiananmen Square. They're not going to talk about the horrible things. If you ask them about the Uyghurs, which are the ethnic group that has been oppressed in China, it's not going to answer that. Sometimes it's just going to choke. Sometimes you'll see it thinking, but it's not going to answer that because it has instructions or it doesn't have the data. But you ask ChatGPT, you ask any of these other models I listed, you're probably going to do that. You get that. So anyhow, there's where that neural network slide got to. I knew I slipped it out there, but we already hit that one. So let's talk about training. Most of us will never train a model. This is like, we might make a model rocket, but we're not going to send one to the moon. So that's like NASA grade training for the most part, for big models. We might train littler models if you're in a reasonable mid-size enterprise someday and you have a lot of data. So you have your logistics data. I interned at a paper company and when I was in college, and probably it has production data, sales data, stuff like that. You might train a small model, and that's where I think Granite is a good choice. But you're probably going to do more of a fine tuning, and that's after it's been trained. And so the thing about the open source models that are cool is somebody has spent a lot of money, and you see what ChatGPT or Sam Altman has said, OpenAI, their training at like 4.0 model was like 100 million, and then DeepSeek said that theirs was like 5 million. IBM is training Granite models, and they're doing the heavy lifting, and then what you'll probably do is fine tune it. And that's a little bit like after it's baked. It's like you went through grade school, you went through high school, it's time to go to college. That's what you're doing, is you're layering on more data and you're fine tuning. And that is a very, very non-technical simplification, but you're just layering on an additional layer of training, and that's what most of us will do. If we do not fine-tune it, the other thing that you can do, and I mentioned it earlier, is retrieval augmented generation. And that's, the acronym is RAG. It's a terrible acronym. It sounds like raggedy, like it's not a good thing, but it is the way that you take a prompt and you take data and you apply it to a model in a way that you can inform your query and get back an answer. So if I go to ChatGPT and I say, tell me about the sales for the AIE for next year. It has no idea. It doesn't see my FreshBooks. It doesn't see my financial statements. So what you would do is you would do a RAG query where you would extract the data, apply it with the prompt that says, I want you to come up with a forecast, and once you inform it and add that data, you can improve the quality of the response. You will get a response from some of these models that will give you a financial forecast based on probability, and they won't say, this is a bad guess. They'll just give you the guess. Now, I think a lot of the models have some guardrails, and they're sort of like the rules. Like early on, there were guardrails that said, try not to, sort of like Google, do no evil, but what does that mean? Now there's sort of like, if you don't know, say you don't know. Or if you're asking for data that could be harmful to somewhere else, you might have rules or guardrails around it so that you can't use those models to do that. If you're a black hat hacker, you probably are taking the open source model and removing the guardrails so that you can weaponize AI. If you're a white hacker, you both have, it's an arms race, you're both using those tools. Next thing we're going to talk about is distillation. So distillation is when one model trains another. So say we got ChatGPT and they're Jedi. Say we have DeepSeek and they're Padawan. And what they did, purportedly, and data scientists tell you, yeah, that's the only way they could have gotten caught up that quick, is they used the output from like the GPT-4 models to train DeepSeek, and that's how they caught up on a lot of vectors. Because Sam Altman already stole the data off the internet, so they're like, well, we'll just use his model to train that model. And he didn't steal it all, he stole some of it, or borrowed it without permission. And so that's distillation, but by deploying these models, you can have the more capable model train the less capable model. And you may not train it to the same level, but you might train it in the same sort of segment of data. So say you want to make a coding assistant, and they have really good coding in Meta's Llama or in one of the other ones. Like, does anybody here use Cursor? Cursor is like the hottest coding agent out there. GitHub Copilot, they might have potentially used those coding capabilities to inform the input for the other model on a specialized model. So just imagine it as like, a really, really well-versed teacher teaching a student, and then the student becomes the grad student, eventually they become a professor based on some of these outputs. So we talked a lot about training. The other thing is inference, and that's the processing that happens when you ask it to analyze data. And this is where most of us are using things today. When we ask ChatGPT, we're not training it. We're saying, here's your data, you're trained, you're the expert, and based on my question, you're going to infer from all your language what the answer is. That's what we do all day long, is when I see, a new dog, and I'm like, oh, that sort of looks like my dog. It must be a doodle. That's an inference, right? So it has this data and applies it to the world. Inference is going to be the thing that is determining our performance today. Here's the thing. Remember I said that we are basically at an understanding of like a 4-year-old? There's one way that you can actually improve that, and that's by running more inference on it, so taking longer to think. And that's called test time compute. So think about this from how many people here are sysadmin or run systems or Linux, and okay? So think about this. What ChatGPT or OpenAI has the problem of, they're just burning money. There's just, their data centers are humming all the time. So if you are, you want the inference to return an answer quickly and not burn up too much GPU. If it keeps running, then it can't run more queries and you hit capacity faster. But if you can make the test time compute longer, then it can think longer. So has anybody seen like prompting tricks like they said, take your time, break this up into steps? That's going to use more inference. And there's two reasons why that works. Is one, it simplifies the problem. But when you say take more time, you're taking more GPU compute to run those test time compute. There's something else that's like long horizon stuff, but that you can Google. I'm not really qualified to talk about it, but I think that's another thing that is interesting. So we hit tokens a little earlier. I just wanted to give you an example of what they look like. Those are the words. I'm going to put my glasses in so I can point to the top or the bottom. So you can see how I have the colored like little blocks. That's taking that and tokenizing that into those numbers for the probabilities. And then if you look at the early days, the context window or the number of tokens that you could put into a query, it would take, it's not words, so I use like this little conversion at the bottom. Say you wanted to summarize a piece of text, you would know that piece of text, if it had 4 characters in English, is basically 1 token. It's not perfect because you can see that the tokens are in little different shapes. And that's important for these context windows. So that's what the token limit is a context window. So think about a conversation we have at a cocktail party. At the beginning, this happens to me all the time. It happened to me the other night. I was at dinner with my friend Joseph, and we met 3 guys. I remember everything about them except names, because at the very beginning, we all introduced our names. I know that like Dan, who I remembered later, he works at Anduril, so he gets to play with the world's coolest robots. And I remember that. I couldn't remember his first name. It was driving me nuts. I sat next to Chris. I'm like, man, all I can think of, his last name was Wall, and I was like, all I can think of is Electric Shaver. I couldn't remember his first name all day today until like right before this. So that's the beginning of my context window. So say my context window, instead of being tokens, was just a half an hour. And we went to dinner and we were there for 3 hours. What happens is that it's hard to remember what happened earlier on because you only have so much short-term memory in that. That's how these context windows work. So what you typically do is if I had something bigger than my context window, say my context window, and I'm just going to use round numbers. My context window was 100, and I had 1,000, tokens worth of context. What happens is it remembers just those within that window. But what you can do is take that 1,000 words and chunk it. And what you think about it as, I chunk it into a little bit more than 10 chunks because I don't want it to just chunk at the ends what the original, and there's other ways to chunk, but the first way that we really looked at it is you do an overlap. So the last sentence would overlap into the next one so that you would know that it could put those pieces together, and that's how you get around the context window. So if you wanted it to analyze a book, and you knew the context window was 100,000 tokens, and you can use something called a tokenizer to tell you how big, you might say, oh, it's not going to be able to do this well because it's outside the context window. It's probably not even going to do it all that well if it's a big context window anyhow, because it's hard. What you want to do is try and break it up into logical sections like chapters and have it do it chapter by chapter, and then combine the summaries into one summarization. Next thing, feedback loops. This is the important part. Like, we can train it, we can fine tune it, but it's not going to be perfect. So that's why I was talking about the little thumbs up, thumbs down in these chat bots to give feedback loops. You might have, that's a user validating or not validating that. You may see that if it's a coding agent, it might write code and then write a unit test and it fails the unit test, then that's implicit feedback. You also have these sort of old school machine learning tests. Like you can have error tests, there are F-scores, there's all these things that have been around for machine learning algorithms for a while, and there's new tests coming out, but this is part of what we call evaluation. So if you're monitoring person right now, you might use observability. Think of this as evaluation as observability for LLMs. This is going to be the hot thing for people that are putting AI into production this year. But the best one of all is probably going to be human in the loop, because remember, 4-year-olds, I may act like a 4-year-old, but I'm a little smarter than one, and just a little bit. But the humans in the loop are probably the best form of feedback. Unfortunately, my CPU clock speed is not nearly as good as a A100 card in a data center, so I can't keep up, and that's why GPUs or why human in the loop is important, but is just not going to be scaling the same way that machine learning and some of these other things are. I'm going to end up today, we're at 52 minutes, with AI agents. Normally, this would have taken me, I would have gone deep in all of this stuff and given you examples, but hopefully this gives you the overview. AI agents, I think, are the most interesting thing that are going forward. What they're going to do is, today, most of what you get in ChatGPT is like response-based, but these are goal-oriented. So I use about maybe 100 agents that do tasks for me all week long, but the tasks are so simple. But what they do are they create an outcome. So they have, what they are basically, I call them smart workflows today. As we get more and more capable, and you can, like some of the tricks I talked about, like longer test time compute, they can be a little bit better, but they're not capable enough for them to write my newsletter. Or they could, but it would really stink because it doesn't have the human in the loop. What they are good at is if you take a newsletter, there's different parts of it. So there's a title. Titles are super important in newsletter. If you get an email, the first thing you got to do is get it to open. So there's a guy I know who's like the master of this, and I took all of his tips and tricks and FAQs, built a knowledge base for my agent of that, and then I gave it prompt that said, here are the instructions. So I want you to write a headline for a newsletter. In that headline, I'm like 35 characters. This is all geeky newsletter stuff, but these are my specifics. 35 characters usually is about the perfect length for a newsletter title. Having an emoji helps. Having good preview text helps to get it open. But I don't even have my agent. He's just the headline agent. Then I have the preview text, and the preview text is what shows up there. And I said, based on this title and this content, come up with preview text that entices the reader to read. And that's another task. And then I get to my newsletter, and in my newsletter I have a lead. So I have a lead writer that takes the story that I want to tell and writes the lead to get you to want to read the rest of the newsletter. And then I have a feature article. That's another agent and another task. And then I have, the closing. And then I have the metadata that I put into it. So when I publish it on the web, my meta description, my SEO title. My SEO title may be different than my newsletter title. So I have an expert for each one of those things. And then I have a copywriter. And that copywriter goes through and uses certain conventions. Like I use contractions, but if you had a spell checker that said, my 9th grade English teacher, Mrs. Wolf, would not be happy that I'm using contractions in a business setting. But that's my style. I like the M dash. I want to use M dashes. I don't want to use semicolons. I think that's like sort of weird. I want to bold out points. I want to do all these sort of things, and that's the copywriter. And then I have an editor, and the editor, at the end, looks at everything we put together, and it gives me a draft. So I probably started with what's the topic of my newsletter, points I want to bring out, do research on the different trends, and all those little things together. And then at the end, I have my editor-in-chief that pulls it all together. And then the human in the loop is Mark. So that's what it is today. But if you notice, the editor-in-chief, all those little things together is putting together a final product. And it's like 60, 70% there when I get it. And then I'll go through, and sometimes it's cool because it has the search capability and it'll do a little research. So I may have seen one article on DeepSeek, and then Jan LeCun, who's the head of AI at Meta, might have added something. Or Ethan Mollick is a professor at University of Pennsylvania. And those guys are super smart, and they've given some more color. And it might say, hey, well, Ethan Mollick says this, or Jan says this, or Yogi, who's in Toronto, is one of the other godfathers, or Jeffrey Hinton said, yeah, the Terminator's coming, we should all leave. Whatever it is, those different tasks are broken up. It does the research. It gives me 70%. So what makes my newsletter good, or at least in my opinion, is that last 30%. But that's where I'm good. It doesn't take a genius to go run a Google search. It doesn't take a genius to use good grammar. It doesn't take a genius to look at the patterns for what good newsletter titles are. But at the end, it's sort of like when you're a chef in a kitchen, you taste it at the end and you're like, oh, it needs a little more salt, it needs a little more spice, I need to thin it out, I need to thicken it up. That's what you do. And so whether it's writing a newsletter, writing a report, doing research, breaking up everything into tasks is really important. And that's why I think the most critical skill for AI is critical thinking. So if you are someone who codes, you are used to breaking things into subroutines, logical units, accomplishing tasks, that's going to be really good. When adults come to my classes and say, what should I tell my kid to go to school for? They're like, he was going to go for comp sci. I'm like, this is just me, but if it was me, I would not send my kid to comp sci. I'd send them for philosophy because it makes you a better critical thinker. And I think that's the sort of skill of the next 10 years. I mean, there's still all of our IT skills for the next 10, 15 years are still going to be relevant, but the ability to really, and a lot of people get in, and I'm this way, is you get on autopilot and you stop being critical. Well, these agents can go on autopilot for the simple tasks, and that's not what's going to differentiate yourself. So my takeaway here is these are my 3 favorite open source AI projects. I will be totally transparent with you. I use something called Taskade because it's really easy for me to take my ChatGPT prompts and my knowledge base, transfer it over, and share it across with different people. But these are getting really good. Crew AI is probably one of the most popular ones for most people. Creates agents. It's pretty cool. This is really cool. And so here's a funny thing. I ask it to summarize. I'm an open source advocate. I do not use the hyphen in open source because it's a trademark and has a certain meaning. AI and really Grammarly and Webster or whoever has decided there's a hyphen in there. I'm like, drives me nuts. I summarized what I wrote, and I didn't catch it because I didn't use my copywriter that tells me that I don't do that. But Obot from Acorn, if you look on GitHub, is really interesting because what they decided, there's 2 ways that I've noticed people building agents. The first way is it looks like a flowchart. I think that's a terrible way to design an agent. The interface they use is natural language, and it looks like you're talking to ChatGPT to generate the agent and all the actions. I like them. And then IBM has their BAI agent framework. I think that's really cool because not only do they have their own agent framework, but it can manage agents from other domains. So that was 60 minutes on the nose, 8 hours. I will be around for as long as you want for questions, but if you have questions, email me. I put my phone number in there. If you subscribe to the newsletter and respond to the newsletter, I answer every one of those questions. Not in short order, but I eventually answer all those questions. And next, in a couple days, I'm going to launch a free community on Circle where people can ask questions, and I'll have a group of moderators on all this kind of stuff to help out, because the reason I do this is I think this is really going to be disruptive, and I like to teach, and if people don't have resources that are trustworthy, all those scary scenarios about people losing their job and not being, relevant will come true. And I don't think it has to be that way. So I appreciate your time. Thanks for bearing with me as I scream through 8 hours and 60 minutes. And thanks for coming. You're missing dinner or drinks or game night, but I'll be around afterwards for any questions.
Oh, hold on really quick. Yeah, please, thank you. Give it up for Mark here. Really appreciate it.
You want the URL at the beginning? Yeah, if you just go to bit.ly/AI scale and put in your email address, I'll send you the slides, and you'll get my newsletter that you can reply to me with any questions, and I will answer them. Plus some free training stuff that I'm going to put out there that is probably a decent resource. So I'll answer questions.
We have about 5 minutes where we can take some questions before the next group comes into this room. Any questions? Everybody good? You're going to get a lot of emails.
Or am I just going to I'm going to wake up tomorrow morning with like 50 emails, and they're like, you told me not to send my kid to college for comp sci, and I just paid his tuition.
Right.
Sir?
Oh, hold on one sec, please. Let me bring you the microphone.
What can you tell me about Claude AI?
What AI?
Claude, C-L-A-D-E.
Oh, Claude. So Claude is the question is Claude AI, which is a large language model from Anthropic. They're in the same genre and size as OpenAI's models. The thing about Claude that's cool is, like, each one sort of has a little bit of a better thing. The two things I think Claude does is I think it's a better writer than ChatGPT, and it's a better coder in a lot of ways. And the thing that's cool about Claude is something called artifacts. So you can create like a project, and it's like a group of chats where, say you're going to write your own web server. You could iterate over and over within that artifact and then publish it. I think what we are going to do is a lot of us are going to write our own personal apps in the future, and Claude is pretty good about not just writing the code, but deploying it. It is proprietary. The other thing I don't like about Claude is it doesn't have the web search, which means that you've got to, like, if I wanted to analyze my, newsletters, I have to load the newsletters in there, and that's just an extra step, whereas, the web search indexing that ChatGPT is. But it's pretty affordable. They're all pretty affordable. I will tell you that there's two things that I really like that is Claude doesn't have they have something called a computer use model, which is interesting, is they can actually orchestrate and do things on a computer desktop. I think that's another thing that's interesting about them. But the stuff I like right now that I think is the most powerful are things that do deep research. So ChatGPT has the capability to do deep research. If you want to shell out $200 a month, they have their ChatGPT Pro, and they allocate a lot more compute time for the deep research. The better deal is Gemini Advanced 1.5 Pro. They do deep research, but that's $20 a month. So that's my overview. Is Claude, I think, good writer. So a lot of times I'll do my thinking or on something called Canvas, which is a ChatGPT thing where it's sort of like Claude artifacts, and I'll cut it, paste it into Claude to do writing. If I wanted to analyze a piece of code, which I don't do a lot of times I'll compare across. So I'm doing my own mixture of experts, but I'm the LLM router, and it's not very technically efficient. Yep.
All right, everybody. Thank you very much for coming.